this rational inequality looks a little worse than the other ones, but really there's only a little factoring to worry about at the beginning, and we can do this. I'm going to use x's here because it's easier to talk about x-intercepts that way. If you factor the top numerator of this fraction, you get x minus 4 and x plus 1, okay, and you have divided by 2x plus 1. And then we have this greater than negative 2. And remember the thing we always try to avoid, you may not multiply by the denominator when you're dealing with inequalities. If you do, you might unintentionally flip that inequality around depending on whether your denominator is positive or negative. We don't want to do that. So instead, we're going to add 2 to each side. Okay, I need to add 2 to each side, and this is going to be x minus 4, x plus 1 over 2x plus 1 plus 2. And to give it a common denominator, I'm going to multiply it by a crazy 1. 2x plus 1 over 2x plus 1. Now I can add these fractions together, and the result will be greater than or equal to 0. So, doing that, we're going to need to FOIL this. So we get, so maybe it wasn't great to FOIL it, to factor it in the very beginning. Oh well. Lessons learned. X squared minus 3x minus 4 plus 4x plus 2 all over 2x plus 1 greater than or equal to 0. Okay, combine some terms, simplify this, and we get x squared, blah, 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 plus x, and looks like a minus 2 to me, over 2x plus 1 is greater than or equal to 0. And now we can factor it. This time, it's a good idea. We get x squared, x plus 2, x minus 1, over 2x plus 1. And that's greater than or equal to 0. Okay, this is the form I want. I want rationals where it's a fraction on one side and greater than or less than 0, with 0 on the other side. That whole negative 2 business was going to be a problem for using a sine array, but with the 0, it's much nicer. So now we go about building a sine array. Okay, and I'm going to talk about 2 things. I've got a vertical asymptote right here at x equals negative 1/2. You should know how to find vertical asymptotes by now. So I'm just going to put that here, negative 1/2. And what else do we have? Let's take a look. I've got some x-intercepts. Okay, my x-intercepts are at 1, 0, and looks like negative 2, 0. So I'm going to put those x-intercepts on this line also. There's 1, and there is negative 2. Your line does not have to be to scale. Now we put the factors on, and this is going to be x plus 2, x minus 1, and the factor that was responsible for the vertical asymptote is 2x plus 1. So now we figure out the signs. 2x plus 1 is positive above negative 1/2 and negative below negative 1/2. X minus 1 is going to be positive above 1 and negative below 1. And x plus 2 is going to be positive as long as we're above negative 2, but as soon as you go below negative 2, it's negative. So now we multiply these together. Okay, I'm multiplying down, and we get a negative sign, a positive sign, a negative sign, and a positive sign. So now we have to go back to our original inequality and say, what is it looking for? Well, it wants greater than or equal to 0. So where is this thing positive or equal to 0? And that's going to be at some places here. So we have negative 2 through negative 1/2. That's one positive interval. And the next positive interval is 1 through infinity. Okay. Now the question is, what type of brackets or parentheses do we put on these things? Well, you might be tempted to say, because it is greater than or equal to 0, it's all going to be brackets. That's not quite true. X-intercepts are fine. If I say x equals 1, okay, I'm looking at this one right here. If I say x equals 1 and plug that into my equation, yes, I do get 0 in my equation. But there's one that causes me problems. What if I use x equals negative 1/2? If you plug in x equals negative 1/2 into that equation, you're going to get a 0 on the bottom. That doesn't produce 0 for your result. It produces infinity. So we can't have that. This one is not going to be a square parentheses. That's going to be a curved parentheses. And that's going to happen anytime you're dealing with a vertical asymptote instead of an x-intercept.